Module 2, Lesson 1, Explain 1, found on page 64. So a vector is a quantity that has both direction and magnitude. And magnitude, you can kind of think of it in terms of how much in that direction. So just because I turn left or right, magnitude can be an example of how far do I go left or right. The initial point of a vector is the starting point. The terminal point of a vector is the end point. So you can kind of think of terminal usually means the end of something anyways. To terminate means to bring to an end. The vector shown may be called vector EF, kind of like you might have line, segment, or ray, but note that at the very top it only has a single spike to it for the arrow. It doesn't have the full two sides of the arrowhead, or just vector. Right, so that is some vocabulary: initial point and terminal point of your vector. Please note that just kind of like an end point, that the E is at the end point, and the F is at our terminal, or where thing ends up stopping at. So where it starts and where it stops. Okay. Translation. So it is convenient to describe translations using vectors. A translation is a form of transformations. So transformation, remember, in general means to change. Something is changing about the shape. A translation is a form of changing. Along a vector such that the segment joining the point in its image has the same length as the vector and is parallel to the vector. So if you translate something in language, the important part of translating something from one language to another is to not change the meaning as much as possible, in trying to keep the original context. And that's where the translation comes from. And you can think of it that way for translation of a shape, is that we're keeping the original shape in its origin, and we're simply just shifting it from one spot to another spot, kind of like from one language to another language. So it's being translated. And along the vector is basically the path that it is taking and being moved. What direction and by how far is our vector. And so each point would shift the same amount along that vector and that movement. And so they should all be parallel. And this is important if you ever create three-dimensional objects, is that just that from one point to the other point, unless it's like decreasing in terms of getting smaller and going to a vanishing point, most of the time they will all be parallel. For example, B prime is a line segment that is the same length as is in parallel vector. All translations. Parallel lines are always the same distance apart and never intersect, and parallel lines have the same slope. And that's essential not only now, but also later on in some of the other future assignments, that parallel lines have the same slope. The only thing that changes is usually their intersect with the y, where they move up and down. It doesn't matter. They have the same slope. Example 1, draw the image of triangle ABC after a translation along the given vector V. So we have been given not only our starting point, which is here, But then we also basically have a slope of where it's going to be traveling to create its endpoint. And what you'll see is that this is going to be moved basically up to and over 1, 2, 3, 4. That's its translation of every single one of these points is going to move by the same ratio to find the next point along this vector, aka this line. So draw a copy of vector with its initial points at vector A of triangle ABC. The copy must be the same length, because that shows you what direction and by how far. And it must be parallel to vector V. Repeat this process with all of the vertices at B and C. So what they're saying is that this line here, this line here, this line here, and this line here are all parallel because they all have the exact same slope. And then they have the same distance along that slope, and each point is moving at the same time. All right? So then you can take the points where they end at, the terminal points, reconnect those terminal points, and recreate the triangle for A prime, B prime, and C prime. So for B, you're going to want to do the same thing. So go ahead right now and you can pause the video, and for B, using the vector that they give you, you're going to translate point D, well, A, B, C, and D by that vertex. So each point's going to move 1, 2, 3 to the left and up 1, 2, 3, 4, 5. Draw and plot A prime, B prime, C prime, D prime, and connect them to create your translated image. So go ahead and pause the video and do that now under B. Okay, so let's see what you should have done. So hopefully your image looks something like that. So draw the vector from the vertex A. Remember, vertex just means corner. That is the same length and parallel to vector V. All of these lines here, line segments here, are parallel. The terminal point A prime will, go ahead and try to fill that out, be 5 units up and 3 units to the left. Okay. Draw 3 more vectors that are parallel from B, C, and D to the terminal points B prime, C prime, and D prime. Draw segments connecting those A primes, B prime, C prime, D prime to form quadrilateral A prime, B prime, C prime, D prime. And there you have it. Okay, so how is drawing an image of quadrilateral ABCD like drawing an image of triangle ABC? How is it different? So take a moment and pause the video and write down how was basically doing example A similar to doing example B. All right. So if you need more time, make sure to pause the video. Otherwise, here's your possible answer. And again, please don't just copy down the answer. This is just a reference. Did your concept match up? The steps of drawing an image of the quadrilateral are the same as drawing the image of the triangle. It is different because there's an extra vector when drawing the quadrilateral. You had one more corner. Okay. Also, you must be careful to connect the vertices in the same order as the original shape. So don't be like trying to connect A to C and then D to B. You want to make sure that they are in the same order and consecutive with these guys up here and correspond correctly. All right, so on page 66, there's a your turn. Draw the image of triangle ABC after a translation along vector V. Go ahead and pause the video and try to do that on your own using example A and example B to help you. Make sure that you've paused the video. Otherwise, we're going to look at what it should have looked like. So that is your translated image that you should have, as you took each point and moved it down 2 and over 1, 2, 3, 4, 5 places. To draw each one of your points are going to follow the same rule to create parallel vectors in a translated figure. Alright, next up is our example 2, or excuse me, my explain 2. And see you in the next video. I hope this helped.